Okay, first question then is showing that f of x equals 0 has a root alpha in the interval 2.1. Okay, so to do that I'm going to look at f of 2 and f of 2.1. If there is a root between those two, I would expect there to be a sign change, and that's valid because we know that the function is continuous in that range. Okay, first thing to do then is set the calculator and make sure it's in radians, and I'm going to start by defining 2 as x, and now I'm going to set up the equation in the calculator. X cos x minus 2x plus 5. Okay, we've got f of 2, x is already defined as 2, so f of 2 is 0.1677. I'll do to 4 dp. Now redefine x, 2.1. So that's stored 2.1 as x now. Back up to the equation I want, equals minus 0.2602 40p. So I got the sign change. It's a continuous function, therefore be a root between 2 and 2.1. Notice it's a root, it doesn't say there's only one root, always shows that there is at least a root between 2 and 2.1. Okay, part B is looking to use Newton-Raphson to establish a more accurate answer using a first iteration of 2. Now, Newton-Raphson says that x2 is going to be x1 minus f x1 over f dash x1. Okay, we've got f of x up here, so f of x equals x cos x minus 2x plus 5. That's a product, u and v, so f dash x equals x times the derivative of cos x, which is minus sine x, plus cos x times derivative of x, which is 1, so that's just plus cos x, minus derivative of 2x, which is minus 2. And to tidy that up, equals cos x minus x sine x minus 2. Okay, so we're now in a position to get x2 equals 2 minus f of 2 all over f dash of 2. Now f of 2, using the calculator for that, putting that back into the original function, which is here, I'm going to do 2 cos 2 minus 2 times 2, which is 4, plus 5 equals 0.1677. And I'm just going to store that as A for accuracy. F dash of 2 is going to be cos 2 minus 2 sine 2 minus 2, which is minus 4.235. I'm going to store that as B. And so I can now do 2 minus I get an answer of 2.0396. And what does it want? It wants the answer to 2 decimal places. So that equals 2.04 dp. Part C is just asking to show that the answer to part B, so 2.04, is correct, gives alpha correct 2 decimal places. So we're going to look at the upper bound, 2 decimal places, the upper bound of 2.04, 2.045, and the lower bound 2.035. So if I look at f of 2.045 and f of 2.035, if I get a sign change with those two, knowing that the function is still continuous between those two, again 2.04 must be a solution to 2 decimal places. Okay, so f of 2.045 equals, okay, calculator time again. Let's put in 2.045. I'm going to define that as x, and I've got my original function, which is x sine, oops, x cos x minus 2x plus 5, and so 2.045 gives me minus 0.238, sorry, minus 0.0238. F of 2.035, so 2.035 equals, store that now as x, run that back into the formula, and I get 0.0189. Sign change, continuous function, therefore root 2.042 dp.